9.4 Solution concentrations. The learning goal in this section is to calculate the concentration of a solute in a solution. And then we're going to use the concentration as a conversion factor to calculate the amount of solute or solution. Now, the concentration of a solution is expressed as the amount of solute over the amount of solution. And we have different units of concentration, i.e. different items that we can have formulas for, whether it's mass percent, mass over volume percent, mass volume percent, or molarity. So let's do each of these. Mass percent is the concentration by mass of a solute in a solution. It is the grams of solute divided by the grams of solute plus grams of solvent. Or another way to say those items right there is the mass of the solution. When water is added to 8 grams of KCl to form 50 grams of a KCl solution, the mass percent concentration is 16%. Let's figure out how they did that math. Well, the grams of solute, which was the KCl, is 8. The grams of the whole solution was the grams of solute, which was 8, and the grams of solvent, which was 42. Add them together, it's 50. 50 times 100 is 16.0%. Now, press pause and see if you can do this problem. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. Calculate the mass percent of the solution. Well, our formula is grams of solute over grams of the whole solution, which is the grams of solute over grams of solvent. So when we do that, you will notice the grams of solute is 15 grams of sodium carbonate, and the grams of the whole solution is 15 grams plus 235. Now then we do all that times 100 and we get 6%. Now, volume percent is the percent volume of a solute liquid to volume in milliliters of solution. That's the kicker. Make sure that you realize it's in milliliters, because some of these others it's in liters. Now, mass volume percent is the percent mass of a solute to volume of a solution. Again, in milliliters. Make sure you catch that. So it's going to be grams of solute over milliliters of solution times 100. Now, this is the formula widely used in hospitals and pharmacies for the preparation of IV solutions and medicines. Now here, let's have a question. What's the mass volume percent of a solution prepared from dissolving 25 grams of NaCl in enough water to give a final volume of 2.0 liters? Well, we need to go ahead and go grams of solute over milliliters solution. So we have to convert from 2 liters to milliliters, and remember milli means 1,000, so we're going to multiply by 1,000, so that's 2,000 here, or move our decimal 3 places to the right, same thing. So the mass over volume percent is 25 divided by 2,000 times 100%, which is 1.25%. Now, molarity is another unit of concentration, and in chemistry it is used more often. So it is the moles of solute over liter of solution, and it's defined as moles of solute over liter of solution. Notice here it is liter, not milliliter. Now, solve using the formula molarity equals moles of solute over liters of solution when we're solving our formula. Molarity, which is also written big M. So we have a sample of 0.341 moles of iron 3 chloride. It was dissolved in water to give 25 milliliters of solution. What's the molarity of the solution? Well, we have to make sure we realize it's just moles of our solute. We had to convert from milliliters to liters, so we're going to divide through by 1,000, meaning move our decimal 3 places to the left. So when we do that math, we get 1.36 molar iron 3 chloride. Now sometimes the question gives you grams instead of moles. And since a mole, we learned back in several chapters ago, a mole was grams over molar mass, then you can substitute this into the equation to solve for molarity. So here's another formula you need to write down. Molarity is grams over molar mass over liters of solution. And you go, well, why don't I just use moles right here? Well, what if they give it to you in grams? Then just use it to convert. So here's an example. A sample of 15 grams of iron 3 chloride was dissolved in water to give 35 milliliters of solution. What's the molarity? Well, we look up the periodic table to figure out the molar mass of our iron 3 chloride and iron is 55.8, chlorine is 35.45 times 3. When you add it up, it's 162.2. Now, our molarity is grams over molar mass over liters. So 15 divided by 162.2 divided by 0.035 liters. Here's another problem. What is the molarity of 0.500 liters of NaOH solution if it contains 6.00 grams of NaOH? So since it gives us grams and asks for molarity, we can use our formula that we just learned. Molarity equals grams divided by molar mass divided by liters. We look at the periodic table to figure out the molar mass of sodium hydroxide, and it ends up being 40. So molarity equals 6 divided by 40 divided by 0.5. So our molarity is 0.300 molar NaOH. Now, here's the same problem. If you didn't want to plug and chug into formulas, if you wanted to use dimensional analysis and think about it more, this process here does this. Now, I personally, when there's formulas that I can use, I personally prefer going the easiest route, which is using the formulas. But you may want to do this instead, so whichever one ends up working for you. So we think about what's given. We know our ratio by looking up the molar mass in the periodic table. We have this. Starts with 6 grams of NaOH. We're going to convert from grams to moles here, and then we're going to continue on and plug it into the molarity formula here. To me, it gives me too many different places to mess up. I like to have it all in one place. But this is more of a thinking method, so feel free to do this. All right, here's another problem. What's a molarity of 0.225 liter of KNO3 solution containing 34.8 grams of KNO3? Press pause and come back. Now, you'll notice it gives us grams, and it asks for molarity. So we figure out the molar mass, and I would plug it into this formula. Molarity equals grams over molar mass over liters. So we have 34.8 grams is what's given. The molar mass is 101.11 grams per mole divided by our liters, 0.225 liters, and we get 1.53 molar. But again, this is a plug and chug way. Let's do it if you also want to look at it where the thinking method. You can think about this. You're going to go from grams, and you're going to use your grams to moles conversion by doing this to get here. Then we plug it back in here to our molarity formula to solve for it. I don't care which way you use. Now, sometimes the question asks you to figure out the grams, but gives you the molarity. So instead of giving you the grams and asking molarity, it's going to do the other. So let's rearrange the formula. Here is the rearranged formula already for you. I'd write this down somewhere. What mass of potassium nitrate is required to prepare 155 milliliters of this solution? Well, we need to figure out the molar mass, and so we have the molar mass. We also need to convert the 155 milliliters of our solution to liters, and so we're going to move our decimal places 3 places to the left, and when we do, we get 0.155 liters. So when we multiply all this together, we get 3.92 grams. Here's another problem. Go ahead and solve for this. Press pause. All right. How many grams of aluminum chloride are needed to prepare 125 milliliters of this 0.150 molar solution? Well, we're just going to go grams equals molar mass times molarity times liters. Let's see, the only thing tricky there, after you find the molar mass, is you got to convert from milliliters to liters. So we're going to move our decimal 3 places to the left because this is milliliter and we need to get to the bigger number, the liter. And so you have 133 times 0.150 times 0.125, and you get 2.50 grams of aluminum chloride. Now, I wanted to show you this other way to do this in case you don't want to plug and chug if you want to think about it more. We need to go from the liters of solution and use our molarity to the moles of solute using the molar mass on the periodic table to get to grams. And so we have our different equalities and conversions. We have to figure out which ones to use. We set this problem up and cancel out through dimensional analysis, unit cancellation, and you will see we're going to get the same exact answer. Now, sometimes the question asks you to figure out moles or volume, and it gives you the molarity. Well, just rearrange the molarity formula to solve for what they're asking for. So, again, here's our original formula. Molarity equals moles of solute over liter solution. So let's say they said, how many moles given this molarity and this volume? Well, then it's moles equals molarity times liter, and that's a rearrangement of this. Or let's say they wanted to say how many liters, and they give you the moles and they give you the molarity. Well, that formula is moles divided by molarity. I would write this formula down too to be able to use.